Why is my GPU dying? Well, that's a question a lot of people have asked themselves in the last few years, because it seems like a lot of 40 and 30 series cards are having problems and lots of issues. And this is something I want to discuss today, because it seems like a problem from the past is coming back today, at least kind of. And I want to show you how you can prevent your graphics card from dying and how to extend its lifespan, basically. So, what is happening right now? Well, you see more and more, especially high-end graphics cards such as the RTX 4080 or 4090, having issues with, outright dying, showing no picture, crashing, artifacting, whatever. And this has a couple of causes. First of all, new GPUs are very, very power hungry. If we look at the TDP of a 4090, that can reach up to 450 or sometimes even more watts on a custom design, especially if you try to overclock. And that is the reason why these cards are dying. And in particular, the reasoning, if I explain it further, if you don't want to hear the technical background of that, skip forwards, but I'm going to explain a little bit why that is actually the case. It is because the cards are manufactured in such a small manufacturing process, and therefore the energy density within the cards is very, very high. This is also the reason why they are so hard to cool nowadays and we need massive coolers. If you look back at, for example, the Fermi days, such as like this GTX 580, which had a relatively small cooler, but still had a TDP of 250 watts. Yes, it was very loud, but still was coolable by then. In theory, you would say, yeah, these cards were much more efficient. No, they were just lower energy density, because this is a 40 nanometer card. Cards nowadays are 7, 5 or so nanometers, and this makes the transistors within the cards very, very small. And because of that, and also the high power consumption, this makes the cards very hot. Modern graphics cards have a lot of temperature sensors within the chip. So you can only see a few of them, which would be the GPU temperature and the hotspot, which is only a small part of what there actually are. Most of the GPUs you see nowadays have over 200 to maybe even more temperature sensors within the GPU that measure specific spots within it. And that is the reason why you see a GPU hotspot, and why the GPU hotspot can in theory also vary. So the GPU hotspot is not one specific spot that is the same on all cards. It is just the hottest sensor that is on the card. And this is why most of the time these hotspots are quite a high difference in temperatures compared to the GPU temperature. And here comes the kicker. Because the GPU temperature is not really the main thing to go off of, and it is just the average across the GPU, the hotspot is seeing the hottest parts on the GPU. And the hotter the graphics card, and in addition to that, the more power it consumes, the higher is the electron migration within the GPU. So electron migration is kind of hard to explain, but it is kind of a process of degradation within the GPU, which makes the lifespan of a graphics card finite. So you have basically a dictated lifetime of a graphics card, which can be like something around 8 to 12 to 14 years or something around that. So it is pretty, in theory, it is pretty well suited for a long lifespan. So normally a graphics card should at minimum last 5 years, but that can be accelerated if, for example, the cooler design is not executed that well, or for example, if the power draw is over the factory designed limit. Such is, for example, on custom partner designs or on cards that maybe not have the best coolers or are used with a very, very quiet fan profile, etc. So there are many factors that can lead to degradation within the chip. Another thing is the temperature swings within the use of the card are a huge factor. This is not really because the degradation is heavier on higher temperatures by a lot, but it is because the GPU cores are mounted to the interposer, or are mounted with the interposer to the GPU PCB kind of. And then there is a BGA, so a ball grid array that connects the GPU and the interposer and stuff to the PCB. And there is another issue with those cards. While modern graphics cards have kind of gotten very good at this, since they have a zero fan profile and they have a relatively low average GPU temperature most of the time, so the temperature swings between idle and gaming aren't really that high or that great, which was something different with these cards, and that's why those cards were breaking a lot back then. So because they were running at like 30 degrees in idle and like 90 degrees, or a GTX 480 even 100 degrees under load. So newer GPUs do not have that problem that much anymore, although it can still be an issue, for example, in the interposer, which has interposer connectors that you can't see because they are within basically that package. And they have interposer connectors, and not only those, but also the ball grid array, or the BGA socket, if you can call it that, where the GPU assembly is mounted to the PCB, that can develop cracks or errors within the soldering. And this is the issue why maybe cards aren't detected, or some funny issues actually, when cards are detected and Windows runs, but they will only work for like half an hour under idle. And if you try to start a game or a heavy load scenario, like within the first 15 minutes of the PC being on and the card is still kind of cold, you have to kind of preheat the card so that the solder and stuff expands, and then you can run a heavy application like a game, and then it will work, but only when the card is already warm. This is like the thermal expansion of the solder, which can fill up gaps, etc., and maybe cracks that developed over time. And those are issues that can be resolved by maybe reballing the GPU, which can be done by some technicians, although it is quite expensive to do and quite time consuming. There are methods that have been tried in the past, like the baking method that Linus Tech Tips also tried. While yes, that may work for a short period of time, as it can shift the components and the solder and the interposer connects on the GPU slightly. It will probably not fix it in the long term. If you get lucky, it may even work for a few years, but it's not really a long-term fix. So yeah, that's the one issue. It could also just be a software issues. If you experience error code 43, for example, that's most often either it's a GPU defect, or reinstall a driver cleanly, and then oftentimes that is already gone, or reflash the GPU BIOS. That's also a fix that can be possible. So how do you protect your card from, experiencing this? As I said, lower end cards aren't really the issue here, as this is mostly regarded to high heat, high power draw cards, where also in the PCB are quite high heat loads. And how do you prevent this? Basically, undervolting and lowering the power limit of your graphics card, providing good cooling for the GPU and for the complete graphics card in general. So in theory, low power limit and good cooling such as water cooling would be optimal. There's only so far you can go. There is some limitations, but for example on a 4090 you could save up to like 120 watts without losing any performance, because these cards can undervolt so well, and this is amazing to extend the life of your card. And this is also why a lot of mining cards tend to die, although they don't have many temperature fluctuations. They have a lot of power run through them, and the core just degrades over time and may get unstable, and you may need to lower clock speeds or raise voltages on those cards to get them working correctly again if you have used them for mining for a long time and then want to game on it, for example. So that's basically it for graphics cards, why they are dying or why they are dying faster than they were in the past, or at least kind of. I hope you found this video useful and learned anything from it. I wish you a nice day and goodbye.